HCF and LCM. So what we're going to do, I'm going to show you how to work out the highest common factor, that's the HCF, and the lowest common multiple, LCM, of two numbers. Our two numbers are going to be 54 and 30. To do this, we need to first of all split the 54 and the 30 each into their prime factors. There's another clip showing you how to do this, so I've already done it for you. We've got 54 is 2 times 3 times 3 times 3, or 2 times 3 cubed. In the same way, we have 30 is going to be 2 times 3 times 5. What we're going to do now is we're going to put these prime factors into this Venn diagram. Here, Venn diagram is a diagram of two circles, and they, in this case, will meet in the middle where there's some common numbers in each of the lists. So that is in fact going to be our first job. We're going to have a look at the common numbers in the list, the ones in both lists there. So can we see we've got a 2 here, so the 2 is in both lists. So I'm going to cross those two 2's there and write it once in the middle. Have we got any more numbers that are common to both lists? Yes, we've got a 3 in each list, so we're going to cross them out again and we'll write the 3 in the middle as well. Have we got any more? No, we've run out of numbers in both lists. So what I'm going to do now is I'm going to put these two 3's here alone in the 54 part of it. So the 3 and the 3 goes there, we cross them off, and I'm going to put the 5 that's remaining in the 30 circle, in the lone bit of the 30 circle, which doesn't include the intersection. So now I've set up my Venn diagram which displays all the prime factors of those two numbers. To find the HCF, or the highest common factor, it's simply going to be the red numbers in the middle section multiplied together. So my highest common factor in this case is going to be 2 times 3 equals 6. Job done. That's the easier of the two to find. The lowest common multiple is going to be all of the numbers you see on the Venn diagram and inside the circles multiplied together. So it's going to be the 3 and the 3, the two blue 3's you see in the 54, multiplied by the 2 and the 3 you see in the middle, 2 times 3, multiplied by the 5 you see all on its own in the 30 section there. So lowest common multiple, then we'll get a result. 3 3's are 9, 18, 54 then, and then 54 will be 270. So 270 will be your LCM. 270 is LCM. And just to remind you how you work out the LCM, you multiply all the numbers that you see inside this green box, green LCM, together, and that's how you get it. So highest common factor of 54 and 30 is 6, and the lowest common multiple is 270. Now we're going to go on a double-decker London bus. It's exciting. We're going to put these numbers that we found into context. We've got a problem that route A leaves every 54 minutes, so don't count on it if you're in a hurry, and route B leaves every 30 minutes. We're told that both leave at 11 AM. So the question's asking, when do they next leave the depot together? So if we know they leave at 11 AM, first of all, we're going to use our lowest common multiple, because what it means is that the buses will next leave at the same time 270 minutes later than they left together the first time round. So that's how you use the lowest common multiple. So we've worked out the lowest common multiple for the 54 and the 30. So what we're going to do, you add on the LCM, the lowest common multiple, to 11 o'clock in minutes. So first of all, you've got to find out what 270 is in minutes and hours. So 240 is going to be 4 hours, isn't it? That's 4 hours and 30 minutes left over. So you add on the 11 AM to 4 hours 30 minutes to it to give you 15:30 or 3:30. 3:30 in the afternoon. So 11 a.m. plus 4 hours 30 gives you 15 hours and 30, or in AM and PM times 3:30 p.m. So recap there, you've got your 2 bus times, it could be train times, it could be anything. The next time they will leave together, you use that lowest common multiple and you just add it on to the first time. So there we have it, how to find out lowest common multiples and highest common factors when you've worked out prime factors from 2 numbers, and then how to apply that knowledge practically into a problem.